Hey, what's up? We're back for another interview here at Automate Live. My name's Chris Lukey, host of the podcast Manufacturing Happy Hour. I'm joined by Jake Hall, the Manufacturing Millennial, and we also have James Finch with us, the VP of Customer Solutions at Eigen Innovations. So my first question for you is, I'm interested to know what a VP of Customer Solutions does, right? I hear about VPs of services, VPs of customer success, but customer solutions is a new one to me. So how would you describe that?
Yeah, so it's really, it's been an evolution, I would say. I started with Eigen Innovations in customer success. And we kind of merged the customer success function with our solutions team about, I'd say 8 months ago. Okay. And really there, the intention is full end-to-end solution design, development, and deployment, along with the ongoing business development relationships with the customers. So we're really the trusted vision partner for many of our customers, and that encompasses everything from the initial project scope development all the way through to delivery and post-delivery support.
Awesome. So machine vision has been in the industry for a long time, and there's been many solutions, many products, many types of problems that it's been trying to solve. But I would argue machine vision has truly jumped leaps and bounds recently as a result of AI. I would say is creating a massive impact. Where do you see machine vision today? It's not just a quality inspection, solution. It's much more. Can you dive into what we're seeing now with machine vision?
Absolutely, yeah. It's been incredible, the transformation of vision over the years, and certainly, I mean, any factory that you go into, there's tons of vision systems deployed, right? The evolution, really, you mentioned AI, so certainly the ability to perform inspections that perhaps previously were not accessible, or that results were maybe not that robust from, but then also the ability to do more with vision data. So that's something that we talk a lot about at Eigen, is doing more with the vision data beyond just the detection. And when you start to incorporate vision data, so images, along with, say, process parameters, you can start to drive full process optimization with that correlation between, here's what happened on the output, and these were the variables on the input side that influence the output.
And I think what's exciting about that is, when I graduated college, I worked for a distributor. We sold vision systems right away. We sold, basic vision, and then what I would say at the time was higher end vision. And a lot of the problems that we were solving was, is this O-ring in the right place? Is this properly assembled? Is a component properly seated? Is it within tolerance? So we do some line measurements or boundary measurements or area, but it's so much more now, where now we can look at variable defects, where before I would say you were setting a region of interest, and all your specifications and measurements or inspection was done within that region. And you had to know what bad parts you had ahead of time in order to qualify and program to make sure you made good parts. Versus now with AI, it's you can real time adjust for variability and defects that you've never seen before. Is that a result of AI?
Yeah, definitely. I mean, when you think about just the effort that it used to take to
hours and hours and hours.
Yeah, I mean, we were talking with some folks in the booth this morning about setting up maybe 20 different programs for vision solutions on a single station, and the effort that it would take to do something like that. When you look beyond those cases where is the seal properly installed, is the seal at the right height, and you go to those more variable type defects, it's almost impossible to program them in that traditional way. So, a lot of the work that we do tends to be in areas like surface inspection of complex surfaces. Let's say an injection molded part that's got this complex 3D shape and a whole range of different defect types, which might be scratches, it might be a short shot, it might be flash on the edge of the part. When that part then goes upstream and gets painted, you've got a whole other host of complex defects. Those are the types of things that with machine learning or with AI, you can start to unlock with vision that you couldn't have done with those traditional approaches.
I'm curious if you can put this in the context to really illustrate everything we're saying, right? Because one of the big things that stuck out in one of your early answers was, now you can use AI so that vision data can go beyond detection is one of the things I thought I heard. Can you share that in the context of a specific story? You gave that example of injection molding. Maybe take it a bit further for us. So, and you don't need to name company names if you can't, but just a story that really puts this in perspective.
Sure. We've been doing a lot of work on the injection molding side, and there's a great video on our website that actually shows some of what that type of contextualization of the data can look like. And really what it is you see some level of defect that may be occurring, or parts that are trending towards a defect, and you're wondering what are those input variables that could be impacting that type of condition. So when you start to go back and look at the process data on that input end, and say, okay, maybe it's a certain mold injection molding parameter, a pressure or a temperature that is starting to go awry, and that could be influencing the output. That's where you're starting to do a lot more with that data set and moving beyond a pure detection, right? Detection's been done, as you mentioned, for a long time, and if we want to build truly smart factories, we've got to start bringing all of those data sets together and realizing some automated insights for the team on the shop floor, so that it's a much more pleasant experience to troubleshoot as well, no?
Yeah. And so troubleshooting, let's dive into that a little bit. Originally, I would say the learning curve to vision was steep, right? Because vision wasn't just the program, it was the proper lens, it was the depth of field, it was the field of focus, it was the light, it was lighting, and that was like 85% of the problem was consistent lighting. But now all of a sudden, I would say the barrier to entry is a lot less for a lot of companies than it was before, where before you had to have someone who had really 10, 15 years of good vision experience to come in and deploy a reliable solution, where I would say the barrier to entry has dramatically been reduced as a result of AI. What does that create then in terms of opportunities for people in the manufacturing industry and other industries to bring vision in as a new solution to them?
Yeah, it's definitely allowing more folks to embrace the technology and get it into more processes within a facility where maybe it wasn't always you weren't always able to bring vision into those type processes. When I think about our particular tool suite, one of the tools that we have, it's called Vision Twin, and it's really designed to help simulate what the vision solution would be, what the coverage of the part would look like, where you'd position your cameras. So those are things that can make installing a vision solution in a complex process more accessible. From there, we've got other elements of our software suite where we do some really neat work with normalization of image data to CAD, which ultimately unlocks scalability of the vision solution, which has always been one of those challenges, right? So when you think about the ability to more easily bring solutions into facilities, one part is certainly the upfront, getting it configured, getting it set up, getting it trained, but then it's how do I scale it? How do I take it across other similar processes, similar machines, or factories in other parts of the world that maybe are running the same product or similar?
What's the right message for someone that's, let's just be blunt, maybe intimidated by the word AI or artificial intelligence, where they're thinking, I barely just started automating, right? How can I start thinking about artificial intelligence? I love what you described about how, in the injection molding example, it's like contextualizing the data, so that way you're not just detecting defects, but you're detecting the things that would lead to a defect, right? That's an example that really puts it in context for me of, oh yeah, AI doesn't need to be complex and scary. Is there how would you answer that? How to make AI accessible to people that, when they hear it, get a little spooked?
Yeah, I think it's the responsibility of companies like ours that we've got to build the technology to make it easy for them to use, so that it's very simple for them to connect, configure, deploy, and scale. And the easier that we make it for our customers to use the product, the less intimidating it becomes, right? If you're going to give a solution to a customer where they've got to go in and do a ton of work on model training and relabeling of images and that sort of thing, it becomes very intimidating. Mm-hmm. But if you make that easy, I think the bridge is getting shorter every day.
Awesome.
Yeah.
And I know we're getting close to wrapping up on some questions, so I always like doing this. What are some low-hanging fruits that manufacturers who are listening to this right now should be looking for within their manufacturing processes or on their floor that machine vision can help solve for them? What are some applications out there that you would say are great low-hanging fruit, great barrier to entry applications for them?
Yeah, I mean, there's a lot that come to mind, but the ones that I'd say that are less frequently touched,
yeah,
and perhaps because historically they've been more intimidating, would be anything to do with surface inspection. So that's where we see a ton of interest. There's still a lot of folks doing manual inspection of surfaces, whether it's a coated surface or a Class A stamping or a Class A injection molded part or textile. You go into facilities, the easy way to find the application, walk around and see where they're doing manual inspection today, right? If there's 10 operators or 5 operators end of line,
yeah,
and they're all manually inspecting parts, I'm fairly sure those operators would love to do something with a little more value add in the facility, and that's a perfect place to start.
Yeah.
James, I've got a question after this, but a follow-up question to that. I feel like surface finishing is kind of, in many ways, like the default example of, hey, where can AI be used in manufacturing? How many surface finishing applications, let's say here in North America, do you think are actually leveraging AI today?
There are many that are running, but I would say results are still mixed.
Okay.
Right? So we go into a lot of facilities, and you mentioned it at the beginning, just the amount of vision solutions that are out there. There's a lot of those, though, that are not being fully utilized. There's a lot of cameras installed that are turned off on processes. And that represents, I would say, a lot of the opportunity, and you go in and you look at some of these processes where maybe they've tried vision, the solution's there, it's been turned off. There's an opportunity to leverage AI to maybe reinvigorate that existing investment and help that manufacturer unlock the results that they were hoping for.
Is that on the people at that facility then? Is that more of a culture thing to adopting it? If it's been put in, it's like, hey, this looks like a great idea, but it's been turned off. Maybe the right way to ask this is, what's the culture change that needs to go in place to really take advantage of this once it's there?
You definitely want to have the right quality culture within the facility. I mean, if it's a quality-based solution, you need the right quality culture to start, for sure. But beyond that, I think it's all about collaboration. So it's about the relationships between the vendors and the manufacturers, building that trusted relationship, helping them on that journey to get the results that they're looking for. That, I think, is really the key there.
Awesome. Well, James, thanks so much for taking your time today. Thanks for teaching us a little bit more about machine vision and just really how much AI is impacting our industry as a whole. So, Chris Luecke, Jake Hall, James Finch, we'll see you guys soon.
We'll be back.